Hey everyone, we are going to keep moving forward with our statistics unit. So first things first, I want to go through some notes. So if you're following along with the note sheet, we're going to start at the top. So we summarize data with one number called a measure of center. Or this is also commonly referred to as measure of central tendency. The most common measures of center are your mean, median, and mode. Mean meaning your average, median meaning the middle value, and mode meaning the most frequent. So to go ahead and define these briefly, your mean is the sum of data values divided by the number of data items, and this is often called the average. The median is calculated differently depending on if there is an odd number of data items or even number of data items. For an odd number of data items, the median is the middle value when the data values are listed in order. For an even number of data items, the median is the average of the two middle values. And then finally, the mode is the data set that occurs the most often. Data sets can have two modes, and this is referred to as bimodal. Or sometimes there's more. So there can be 3 modes, 4 modes, but usually there's 1 or 2. So let's go ahead and look at an example here. So this example data set is already in order for us. So we need to go ahead and add up the data values and divide them by how many there are. So adding 1, 2, 3, 4, 4, 7, and 9, we get 30. Oops. And there are 1, 2, 3, 4, 5, 6, 7 values. And when we divide 30 by 7, we get 4.29 approximately. And the median is the value in the middle. So if we find the middle value, it is 4, and it is that single value because there are an odd number of data items. And then the mode is the value that occurs the most amount of times. And in this case, the only number that repeats itself is 4. So 4 is our mode. Something I want to touch on is our outliers. So outliers are a value that is far outside of the range of most of the other values in a data set. So using the data set we used in our previous example and adding on this 57 at the end, that 57 is an example of an outlier because it is so far outside the rest of the data values. So something I want to point out is that when we add this big outlier, our mean goes up to 10.875, whereas our median still stays at 4. So the mean isn't actually a good picture of what most of our data is. And our median is actually a better picture of our data. This can also be applied to histograms. So on a histogram that has a normal distribution, considered symmetrical, our median and our mean are either the same value or relatively close to the same value. However, when our histograms are skewed, our mean and our median are usually significantly different, and it actually turns out that our medians give us a better visual of our data than the means. So using this information, let's go ahead and go through an example. So here's an example, and it looks like we're dealing with a histogram that is talking about gas tax in cents per gallon and relative frequency. So the first thing I want to talk about in relative frequency is that we're dealing with decimal points right here. And personally, I don't like dealing with decimal points when I'm finding measures of center. So I'm going to go ahead and multiply every single one of these by 100 so they're a little bit easier to work with. So multiplying each of these by 100 is moving the decimal place over 2. So this would become 5, this would become 10, 15, 20, 25, 30, and 35. And the reason we can do this is because we're doing it with every single one. So it's asking us in this example to estimate the mean, median, and mode. And the reason the word estimate is so important here is because we can't find the exact mean and median and mode because we don't know what the exact data points are. For example, looking at this bin right here, this bin goes from 5 to 10. And it looks like if we're estimating the height of this bin, I would say that the frequency is about 2. So that's saying that 2 values fall in this bin from 5 to 10. Does that mean both fall into the 5 category? Does that mean one of them's maybe 7, one of them's maybe 10? Since we don't know for sure, that's why it's called estimating when we're using histograms. I personally, and it's most often used, that we're going to go ahead and use the lower boundary. Sometimes people will use the upper bound, or sometimes people will use the average of the bins to find mean, median, and mode. None of them give you an exact answer, but we usually use the lower boundary because we don't want to overestimate the mean or median. So I went ahead and wrote out the data points. And the way I did this was I went over and decided, okay, there are 2 5s. So here's 1 and 2 5s. And then I went over and decided there are approximately 4 10s. So here's my 1, 2, 3, 4 10s, and so on and so forth. So my next bin starts at 15. There's about 16 of those. So I wrote out 16 15s and continued. So when you do this on your own, you're going to have to go ahead and write out the data points for yourself. But for the sake of time, I did it for us. So estimating the mean, median, and mode, let's start with the mean. So remember that the mean is adding them all together and dividing by the number of data points. So that would look something in this case like there are 2 5s, there are 4 10s, there are 16 15s, there are 33 20s, there are 13 25s, there are 18 30s, there are 4 35s, 6 40s, and 4 45s. And there are 100 data points. So whatever this number is, we're going to divide that by 100 since there are 100 values. And when I put that into a calculator, I get 2,375 divided by 100, which gives us 23.75 as a mean. So let's look at our histogram and see what that looks like. 23.75 is approximately right here. Okay, and then our median, in this case, we have 100 values. Since that's an even number, we're going to be taking the average of the two middle numbers. And since there's 100, that means we're going to take the average of the 50th and the 51st value. And these are already in order. So I went through and counted up to 50. And it turns out that the 50 and 51st term are those two. So 20 and 20, the average of those two 20s is also 20. So that means our median is 20. So looking at our histogram, median's at 20. And the last thing we need to find is the mode. And what's nice about the mode is that we can actually see what the mode is by just looking at the histogram. And the mode on a histogram is the highest point. So the mode in this case is also 20. Okay, so that is the example we went through. This is the way you would go through estimating the mean, median, and mode of any histogram. You would want to pull out the data and then go ahead and calculate the mean, median, and mode from there. Next, you'll be able to see how we can go ahead and put this data into technology instead of having to write it out by hand and put it all into a calculator like we did on this example.